What am I gonna do? I guess I gotta create a new class now. Add new item. Ship. Pragma wants £sign include what? Well, we're gonna include drawable. We're gonna include poly closed because the ship is going to need a poly closed. I don't need drawable if I got poly closed. We'll start with poly closed. We'll see what else we need as time progresses. Ship. Starting to get hungry. This does not bode well. Okay, so what does a ship need to keep track of? It needs to keep track of the model of the ship. The polyclosed vertices that make up the graphical representation. So we're going to go polyclosed model. And okay. Here's the thing. Structural, we're going to need lots of variables for maintaining a ship. So we're going to divide them up into places. Linear, angular. Alright, so linear is going to be vec2 position. So we need a position of this motherfucker. And for angular, we're going to need float theta. We'll just call it angle. None of your fancy Greek bullshit. Alright, so there's positioning. That's 0th order variables. Now first order. We need a vec2 for the velocity. That's our linear velocity. And we need a float for our angular velocity, the rate at which it is spinning. So we got velocity, we got angular velocity. Now acceleration, we're going to make that a constant. And that's going to be a vec. That is going to be a float. Acceleration. I don't know what number I should put on this. So I'm going to say, 0.2. I just pulled that number right out of my asshole. In case you were interested. Alright. Now float angular acceleration is equal to 0.01. That is the rate at which it spins up. Or down. Alright, so we got position, we got velocity, we got acceleration, angle, angular velocity, angular acceleration. We've got our structural, we've got the model here. I think that is all we need for now. Yep. I was just thinking there whether I want to put the color into the ship or whether I want it to be remain in the poly closed. And we'll leave it in the poly closed for now, but I might change my mind at a later date. Because I think I made it in the ship in the prototype, but I can't remember why. And reasons are important, people. So we're not going to change anything there. All right, so ship. What do we do with our ship? Well, we do we do poly closed drawable get drawable const, and we go poly closed drawable d is equal to model dot get drawable, and then we add the position and everything about the ship in here. So we go transform mate 3 and we do translation by position times mate 3 rotation by angle. So that sets up our ship in world space. Yes. This is the translation, this is the transformation from model space into world space. And then we return D. We give them the D because that's what they want. They want the D. Bitches be wanting the D. Let's add a new thing in here. And that's going to be void update. So we got to update the ship by a frame. We need new variables here, people. We need variables. And the variables that we need are Boolean. We need bool is thrusting. That sounds vaguely sexual. False. We are not thrusting. And bool. No, we don't need a bool. Float. Rotation direction. Or angular acceleration direction is equal to 0.0 f. Put an f on there. 2. All right. We have to update the position, the 0th order variables, and the 1st order, the velocity, depending on whether we're thrusting or rotating or not. Now the question is, which one do we do first? Do we do it 2nd order? Wait, do we do it 1st order, then 2nd, 0th order, or 0th, then 1st? The answer is, what did I do last time? Because that seemed to work okay. And the answer to that is, I don't know. Where's my ship? Where do we got? I did it kind of different in this one, so it's got weird shite. It's got weird shite. Accelerate update. So I did. It looks like I did angular, then I did linear, and in the angular I did. What did I do? Angular velocity is equal to 0. And then I did 1st order first, and then 0th order next. Seems okay. Seems more responsive that way. Okay, so that was really complicated too. Yeah, but I'm gonna do it, and I'm not gonna peek. I'm not gonna cheat. We're gonna do this. We're gonna do it live. Fuck it. So what we want to do is update our angular stuff. And we do that by getting rid of this first, because that's dumb. I guess what we want to do is update our angular velocity by acceleration times direction. So direction is going to be equal to 1 if we're going counterclockwise, which is clockwise. Ah, it's so fucked up. It's okay. You don't understand what I'm saying because I'm just talking in my head. Half of my talking is in my head, so you don't know what it is. But when you're trying to figure out whether something is counterclockwise or clockwise, in normal math, you've got your positive y, your positive x, and your angles are going this way, increasing in this direction. So positive is counterclockwise, which is counterintuitive. You'd think clockwise would be the positive, but no. Positive is counterclockwise, except in our game world, this is flipped. And so this is a positive rotation. So positive is clockwise. You get me? That's what I was thinking in my head. Shit's fucked up. That's what I'm trying to say. Now, 1 is going to be clockwise, and -1 is counterclockwise, and 0 is we're not changing our rotation at all. And you got to multiply that by this. The actual acceleration, which should be constant, by the way. As should this one. These are performance parameters of the ship itself, right? This is how fast it can spin up, and this is how fast it can thrust. So what we want to do is, and it should be simple, we're going to do angular velocity is equal to plus and equals angular velocity, no, angular acceleration times angular acceleration direction. There we go. That's simple. That was simple. And then angle plus and equals angular velocity. Now, we're not going to put any maximums on this, so that means that we can spin up as fast as we want. But for the game, we're probably going to have to limit that. But we'll do that later. All right, so that's the angular stuff taken care of. Now, we can do our linear stuff, which is calculated thusly. If I make this not a bool, I can do it without an if statement. I'm going to make it not a bool. Float. Thrust is equal to 0.0f. Okay. I'm going to do this one without booleans, which is different than what I did in my prototype. So what we're going to do here is we're going to do velocity plus and equals acceleration times thrust. What? What are you... Ugh. I don't trust you in IntelliSense. You're probably just fucking with me again. Okay, what is it? Okay. Was not fucking with me. Acceleration thrust, but we have to take into account the direction that we're pointing, because that's the direction in which we will do. So what we're going to do is we're going to create a vector. We're going to go vec2, and it's going to be 0.0f, 1.0f. So we'll create a vector. We're going to rotate that vector. This is a unit vector. It's in the x direction. Rotate that unit vector by the angle of our ship that our ship is pointing in, and then multiply that unit vector by the acceleration and the thrust, and that will give us our acceleration vector, which we add to the velocity, our delta v vector. So you see, I create a unit vector in standard position of an angle, and then I rotate it by the position of our ship, and then I do some other crazy bullshit, and stuff happens. Makes sense, I hope. Yeah, some people aren't going to get that, are they? So the unit vector has a length of 1, so that means it's not going to change. Its length is going to be whatever we multiply it by. So if we multiply it by acceleration, then its length is going to be equal to the acceleration. And we rotate it by our direction, and it will point in the direction of our ship with the acceleration of our acceleration, and that will be our thrust vector that we use to delta v our current velocity. I hope that makes more sense, because I ain't going to explain any more than that. I am done. Alright, so we change our velocity, and then we do angular first order, then 0th order. I feel like adding comments today. Just a couple. Just for the fun. Just for the fun of it. Alright, velocity. So now we do position plus an equals velocity. And that should be our ship updated. I think I can. I'm going to cheat. Yeah, that's it. Oh, here's a good thing. Here's a good one to put in your hat. Stick this in your pipe and smoke it. If you keep rotating your ship in the same direction, your ship's angle here is going to get bigger and bigger and bigger. And really big angles don't behave well, because as a lot of you know, where's my drawings? As a lot of you know, right? For example, pi over 2 is exactly the same as I'm not good with fractions, people. Exactly the same as 2 pi plus pi over 2, which is like 5 pi over 4. Maybe. Don't quote me on that one, people. But, yeah. And exactly 0 is equal to 2 pi. And so on and so forth. So it's exactly the same. So you can have like an angle of like, I don't know, like 1,000,000 pi. And it would be exactly the same as some other angle that's really small. But the way that the algorithms work for the sine and cosine and so forth is they get less accurate as your angles get bigger. And also floating point numbers get less accurate as the number gets bigger. And they have a maximum, and if you overflow, then shit's going to happen. It's going to be bad. So you want to keep your angles, you want to clamp your angles within about a 2 pi region. And we can do that by making angle equal to f mod f. That's a floating point modulus. And this will keep our angle within 2 pi. If it exceeds 2 pi, it'll just go back to 0, is what I'm trying to say. And that'll keep our angles nice and kosher. Okay, okay. So, yeah. Clamp angle to within 2 pi. All right. That's it for updating, I guess. Now we need an interface to allow us to actually move the ship around, because this will let us update it, but it's not going to let us change the actual thrust or the angular velocity direction bullshit. So, void, we're going to create a very simple interface here. Void thrust. Yeah. Thrust equals 1. Void stop thrusting. Thrust equals 0. Void spin float direction. Why don't you like... Oh, okay. Semicolons are important, people. Angular acceleration direction is equal to direction. Void stop spinning, you motherfucker. Float direction. If angular acceleration direction equals the direction that we're trying to stop, angular acceleration direction is equal to 0. Spin, stop spinning, thrust, and stop thrusting. Those are our controlling functions that will control the motion of the ship. Now, we need a constructor. So ship, get made already, fucker. So string file name, and we're gonna add a position to start this fucker off in. Vec2 position. There. And we do pause, and fuck you. And model. It's gonna be file name. There we go. There's our ship constructed. We'll allow it to start off at 0.0f. 0.0f. There we go. There. Okay. Let's see if that works then, I guess. Maybe. So we need to include this in our game. And let's just try to build that quickly. Look at that. No warnings. Oh, it's so good. It's so good. Why did I put update model in here? That was dumb. I should put it up here with the user functions, because that's where it go. That's how we do. Okay, we don't need the polyclose anymore. It's all about the ship now, baby. It's all about the ship. Ship. We also don't need angle and scale anymore, because that's fucked. So, now we go. First I burped a little bit. Just a little bit. It's okay, it was just a little bit. Now we gotta go in here, we gotta update our ship. We'll just do this. Change that to ship. And everything will be better. Game. So update model. Compose frame. So for compose frame, all we gotta do is we go draw ship dot get drawable. See, I told you it was going to get better, and it did. Very simple. Now here, we got to do a little shit. We got to do a little dance, and then we drink a little water. We got to get... Control E, Control C. I'm going to comment this out. We might need it later, but for now, it's just garbage. What we need our keyboard input. Now to save time, because this is already getting quite long in the tooth, we are gonna copy and paste this. Well, I'm gonna copy and paste it. You're gonna have to type it in. Ha ha ha. I'm a bastard sometimes. Sometimes? But it's just, you know, standard. I shouldn't even have to show you this. You should be able to do this yourself. It's just we get our key, we read in our key, we switch the code, and we handle. Left, right, and space are going to be our keys of choice. So we do ship. Now the names of shit is different because I did it different last time. Ship dot spin. Now left means we want to rotate counterclockwise. So that's going to be spin -1. And we do ship stop spinning -1 here if we release it. So we spin -1 or we stop a -1 spin. Right is going to be the same but different. Spin 1, stop spinning 1. And space is going to be thrust. And stop thrusting already. It's not cool, bro. All right. Build. Now is the moment of truth. Why are... I enabled something weird and now it loads symbols whenever I debug and stuff. It's so bad. I just want to disable that. Alright, so here's a dingle dong. For some reason it started off in that direction. Now, I'm pressing the buttons, it's not moving. Could be frozen. It's not frozen. This is not making me happy. Okay. Start without debugging. Why did it start off in a different spot? This is highly irregular. No, I can't click cancel anymore. Oh, God. Well, everybody, you might as well just go and make a sandwich or... Wait. Okay, we stopped loading symbols, I think. I think we did it. We did it. We did it. Now, the buttons still don't do anything. Let's pause. Okay, we have... Good. We have our dumb bullshit now. Game.go. Let's check out... Let's check out the ship. Now, the position is 0. Okay, I think I know why. I think I know why. No, I don't know. Ship. Angle. Okay, so the angle and the angular velocity are not being initialized. Velocity is also not initialized. Now that doesn't make sense because the ship should be just... It should fly off the screen immediately. Oh, I know why it's not flying off the screen. Duh. Duh. Okay. So that little bout of debugging solved two problems. First of all, you have to update the ship if you want actually to move on the screen. So that's first thing. Update that bullshit. What's your problem? I'm gonna make a new function. Just because I'm here. And this is already super long, so handle input. Toggle there we go. So we're going to do this. So we'll give handle input its own little function here. Make sure it's a member of the game class. And then update model will just be ship.update. I want to put this in input, even though it's not being used in any case. And for game.go, we'll just do handle input, update model. And then draw. Now, the thing that we have to do is position is done. It's fine. Velocity, we got to initialize that bullshit. That is unacceptable. Angle. Start that off at 0. We might want to make it so we can set that in the constructor later, but for now, angle 0. And angular velocity start off not spinning. All right. And position is the only thing that is initialized up here in the constructor. Good. Now we should have less dumb bullshit. All right. Oh, now we're spinning. Stop spinning. Spin, spin, stop. Spin, stop. Oh, and we're backwards. Our thrust makes us go backwards. That's bad. I just went off the screen. Yeah, you're code 3. I got your code 3. I got your code 3 right here. Start without debugging. So, thrust makes us go balls first for some reason. Yeah, no, stop it. Okay, this is incredibly difficult to control, and also fuck it. Okay. All right. So first of all, I said one thing and I did another thing. What I said was that for updating the velocity, we take this vector, rotate it, and then multiply by the acceleration. But what we're actually doing is we're taking this vector, rotating it, and then multiplying it. And both of them are wrong, right? Because our ship's default positioning is it points like this. So when the angle is 0, it's pointing like this. So we want to take this vector and then rotate it. That should be our base vector for the velocity calculation. So what we want to do is make this negative. That will solve one problem. Now if I do this, okay, now we're pointing in the right direction. Stop it. Stop it. Stop. Well, sir, I'm going to take a little break, and then when I come back, I'm going to finish up the ship and the map and all the crazy bullshit. But I need food, and I need to take a waz, so I'll see you guys later. Well, for you guys, it'll be really soon. Alright, I'm back, and we gotta make this dick a little more controllable, because this is redonkulous. Look at this. Look at this. Holy shit. Fuck it. No, stop it. Down. Whoa, there it is. Ooh, and it's gone. It is gone. So, first things first. This thing spins up way too fast. Let's go from 0.01 radians to 002 radians per frame. Acceleration. What else? Well, there's other stuff, but first of all, let's just try this. Yeah. So that's a little more realistic. I don't actually mind this amount of linear acceleration. It's pretty good. It gets us where we're going. What is the next thing that I want to handle? Well, I don't like the situation where we have to spin. We spin up, right? But then to stop spinning, we have to accelerate in the other direction, and it's annoying. I don't like that style of control. So what I want is I want the dick to naturally come, when we're not spinning it up, I want it to naturally come to a rotational stop, if you will. And that is going to require a little doing here. Basically, what we want to do is we'll go if angular accel direction is equal to 0, meaning we're not actively trying to spin the thing up, then we want to apply our angular acceleration in the rotation that is opposite to the current rotation. Now, how do we do that? Good fucking question. Wait a second. Wait just 1 second. All right. How do we do it? Well, we go angular velocity plus and equals, and we want the angular acceleration times negative of the sine of angular velocity. Now, sine, that's not a function, but we want, like, what I mean by the sine is I want a function that will return -1 if angular velocity is less than 1, and +1 if it's greater, -1 if it's less than 0, +1 if it's greater than 0. Basically, I want a function that will return the sine of that. So, CMath. Let's go to reference and see if I can find a function that will do that dumb bullshit for me. Error, rounding and remainder, floating point. Sine bit. What's that? Returns whether the sine of x is negative. True if it's negative, false otherwise. Well, that is okay. But it's not the best. Sine bit. Copy sine. What is that? Float. Copy sine. Value with the sine of the resulting value. -10, -1, -10, -1, -10, 1. Does it have to be 1? I don't think it has to be 1, right? It can be not 1. I'm going to try this dumb bullshit out. I'm going to see what you have to do, copy sign. So, copy sign. Stop that. And we want the sign of angular velocity. There we go. So we can do this as minus and equals copy sign. So we want the value of angular acceleration, but we want it to have the sign of angular velocity, and then we subtract that from angular velocity. This should work out nicely. This is what we want. Now, wait, where's my thing? There it is. Why are you drifting? I didn't even touch it yet. I know why. Ooh. Okay, come back, come back. No, no. It's gone. It is gone. Now I know why it's drifting, but we'll deal with that problem later. So we go this way and then we stop. And then it comes to stop. There we go. So the dick will stop spinning of its own accord if we just release the keyboard. And I like that better. But it doesn't come to like a perfect immediate stop. It only uses its own acceleration in the opposite direction. Now the problem is when it reaches 0, it's going to accelerate in one direction or the other, and it's going to be weird. It's going to be weird is what I'm saying, because how to explain this? So let's say this bar graph represents our acceleration. No, this represents our velocity, our rotational velocity, angular velocity. And here's our acceleration. So we release the keyboard, and what happens is it subtracts this from our acceleration, and that's good. And then next frame it subtracts another one of these from here, and then another one, and then another one. But then what happens is it subtracts another one and actually goes in the opposite direction. And then it subtracts this one from here and it jumps back to here. So it jumps from here to here to here to here, and it kind of drifts. So you get this drifting effect because the acceleration is never quite 0, or not the acceleration, the angular velocity. It's never quite 0. My throat's kind of feeling weird. Had a shower. I might have sung in the shower. I might have been singing Hearts on Fire. Maybe. So what we need to do is we need to check to see if the absolute value, whether we don't care plus or minus, we just want to know if the magnitude of our velocity is less than or equal to our acceleration. Now, if it is, then we don't want to subtract anymore. Wait. Leave that. We just want to set it to 0. So what we do here is we go angular velocity equal to 0.0f. So if it's already less than acceleration, just set it to 0. Else we do our normal subtracting thing. And this will allow us to come to a perfect stop. I think I've talked about this before, but I've never actually done it. And basically, we're moving right now in our game. We move at a constant speed per frame. So maybe, let's say we're moving at a certain speed, 1 pixel per frame. So for me, I think my monitor is running at 60 frames per second. So that would be 60 pixels per second. But for someone else living in another country with a different monitor, running at a different refresh rate, they are going to get a different speed for their game. So in their game, the game may be running at 70 frames per second. So then the ship is going to be moving faster. And that's not really a good situation. See, back in the day, when you had like games written for the SNES, they would usually lock the game's speed to the frames. And if you ported a game from, for example, the United States to the United Kingdom, it would run slower in the United Kingdom because their TVs ran at 50 hertz, whereas the TVs in North America ran at 60. So yeah, problems would occur. So we don't want that. In an actual game, that's not good. So what we need to do is every time we update, we need to scale that update by how much time has actually passed since the previous frame. So instead of having a set amount of, for example, acceleration per frame, we want it acceleration per second, which is the normal units that we use in everyday life. So what we do is we add a new thing here. We call it float dt. That's delta time, the amount of time that has passed. And we use that in our functions. For example, we multiply this by dt, and that will scale by the amount of time that has passed. And angular acceleration times direction times dt times dt. Got to get that dt in there, people. And in here, so we're just multiplying all these ones by dt. And that's all you need to do. And now we're not locking the speed to a single frame. We're locking the speed to the actual time that has passed for the user. Now that's going to make these numbers wrong. We need these numbers now to be about 60 times bigger because, well, for me personally, my game's running at 60 frames a second. So this 1 times 10 times, so we want acceleration to be 12. And the angular acceleration is going to be same thing, right? 0.12. And all the rest is fine. So now we need to pass our update a dt, which is a time step. So we go to game.cpp. Now we need to calculate the amount of time that has passed between one frame and another. So what we're going to do is we're going to create a timer. We've used this before in the tutorials. It's a little timer class I've created. Get time milli. Don't know if I want that. Float get time in seconds. And I'm just going to add a function in here. Where is my timer.h? It's in the framework. Timer.cpp. That's what I wanted. Get time milli. Interesting. I don't know why I chose my thing to work in milliseconds, but what did I do in my other thing? That's what I want to know. That is the question. Get time sec. So I did that. Where's timer? Okay, I did that. At least I'm predictable. Now, how did I handle it in here? I just divided by 1,000. Okay, fine. That's what I was going to do. So I'm nothing if not predictable. Return get time milli divided by 1,000.0f. Timer. Okay, now it's time to go back. Go back further. Oh, too far. There we go. Now we create, we need a timer in here. We need a timer up in this mofro. So we'll go to game. No, we'll go to game.h. And we will create timer. Looks like I already included it for some reason. That's good. We will toggle. Ooh, I didn't want to toggle that. I want to go to game.cpp. All right, so now we go. That's a good question. How do we start the first frame? Timer get time seconds. Constant float dt is equal to get time. And then timer dot start watch. Calling start watch resets the timer. So then we just pass dt to here, and it should be good. Shouldn't make any real change. Shouldn't see any change here. Well, it's not moving. It's moving incredibly slow. Okay, looks like my math was off at least. I have solved the mystery. So because acceleration is something squared, I would actually have to multiply by 60 squared to get the same value. So for example, let's undo this. This was my old values when I wasn't dividing by 60. I have to multiply this by 60. Yeah. There we go. Check it out. Check it out, people. And take this one, multiply this one by 60 by 60, and build that motherfucker. And now I should have about the same speed that I had before. Whoa! Come back! Whoa, there. Not good. Let's try that again. That is weird though. It stops almost instantaneous. That's a weird thing. That happens. So the deceleration when we're releasing the button is too fast. Why is that? We're multiplying by dt. Angular velocity minus and equal copy sign angular acceleration times angular velocity times dt. Otherwise, angular acceleration direction times dt. Wonder what this copy sign is actually returning, because it seems, I don't know. I'm suspicious. Let's start the ship off somewhere a little better. Where is my dumb initializer thing? Here it is. So we'll start this ship off in the middle of the screen. And we're going to debug. Wait, we're going to set this one to debug. Okay. Now we spin it up. We let go. And here we go. All right, where's my windows? You're killing me here, Visual C++. You are killing me. Want some autos in this mother? Angular velocity is 8. Angular acceleration 72000. Okay, that seems about right. Let's, I don't know, step over. Copy sign returned 7. Which makes sense. Angular velocity 8.64. Continue. $8.642. I think I figured out what the problem is. Although it wasn't really by means of the debugger. Here, we're saying if the angular velocity is less than the acceleration, then set it to 0. But what we really should be saying is acceleration times dt. Because that's how much you can accelerate in a single frame, is the acceleration times dt. And we want the single frame acceleration if it's less than, if the current velocity is less than single frame acceleration, just stop to 0. So what we need to do is multiply that by dt. And we start this mother up. We accelerate and decelerate. Perfect. Now things are looking up in the spinning space dick world. All right. So I like our control so far. Our dick control. Now we can add, later on if we want, we can add limiters to limit the top speed and limit the top acceleration or rotation. But for now, I'm liking it. I am liking this, people. All right, so now we have our update, and it is tied to real time instead of frame time. Now we need a world in which to move. So this should be easy. This should be easy. We're gonna project, add new item, map. And we're just gonna copy ship, because ship and map in some respects should be quite similar. In other respects, they will be completely different. And so ship is not going to have any kind of position or rotation information. It's not going to be thrusting. It's not going to be updating. It is going to have a get drawable, but it's also going to be polyclosed. So it's going to be the same, except no transformation. The drawable will just be sent as is. So we'll just return model.getDrawable. And we don't need this. We don't need this. We got to name it map. And I kind of think that's all we need for now. Let's look at my prototype, see if that... Oh, my prototype is going to be way weirder because of all this other bullshit. But it's mostly just what I showed you guys. Yeah. Okay, so map is super simple. And now we actually need the map file, which you can download on the website, but I don't have that. So what I'm going to do is I'm going to go into my prototype, one of them, and I'm just going to find map, copy that, and we want to put the map into, what is this, thrust? Engine? Yeah, I'm going to put it into engine here. Yeah, here's the ship D. So we'll paste map in here. And what else? I think that's it. So let's incorporate map into our game. Go to game.h. # include map. Ship map. And now we go to game.cpp. map.dxf. And we should just be able to draw our ship. Camera.draw map.getDrawable. There we go. And that should be it. The problem is, I don't know exactly where anything is on the map. So I've got the dick. I can't tell because I can't move. So what we need is we need to be able to... Wow, stop it. Stop. We need to be able to scroll along with our dingle-dong. And so let's make a function for that. We're going to go into ship, and we're going to create a... First of all, we're going to include camera. And these are our control functions, by the way. And here we're going to do void focus on and camera const. So this function will focus on the current ship with the camera. And all we do is we go camera dot move to and the position of the ship. There's a nice simple function, and it's nice because it doesn't expose any of these hidden variables out to the outside world. You pass it a camera and it focuses that camera on the ship. It's a very elegant design, if I do say so myself. So in the game, we go handle input, update model, camera, wait no, ship dot focus on with camera. I could put this like in update model or even in the beginning of compose frame, but I guess I'll put it in compose frame. It seems kind of like a view sort of thing. So compose frame, focus on the ship, and then draw the ship, and then draw the map. Build solution. Now is the moment of truth. Because we haven't actually... Okay. So I'm moving the dick now. You can't tell because you can't see any of the walls or anything. I can't see anything. I don't know where anything is in the world. I have no idea. This is a problem. Okay. So I can't tell if I've loaded my map properly because I can't get to my map. I don't know where it is in the world. This is a problem. How am I going to solve this dumb problem that I've created for myself? Well, friends, I know I started my ship in a good position. Here we go. Here's where I start my ship off in my my test program. So if I start my ship off in that position here, but I have to change the sign here because of reasons. Should be okay. So this should show me bullshit. No, stop it! Oh, I didn't want to. I pushed buttons I didn't want to. Ah, here we go. Okay. So we've got a map now. And it's totally fucking up the stuff on the bottom, as usual. But we can now move around in our world with our dick ship. And it's looking okay, I guess. It's okay. I don't mind it. Except for the fact that we're fucking, you know, moving through all the walls and bullshit like that. But that is what we're gonna fix in the next lesson. That's the dessert, my friends. Alright, so at least we can move around in the world. Okay, this is now Future Chili talking. I am coming at you from the future. Well, at least with respect to the guy who recorded the footage that you were just watching, because this is a little bit of post-commentary, if you will. Another installment of Chili Done Fucked It Up. You get this one even before the episode is over. That is amazing. I'm so good at fucking it up. Okay, so what did I fuck up? Well, there's a couple of things. A couple of them are small. One of them is quite large. That's what she said. So let's get to it then, shall we? Let's go to game.cpp. Let's see where Chili fucked it up. So how does our system actually work here? I'm coming at this after a week, so I forgot completely. We've got camera.draw, and we pass it a ship.getDrawable. So far, so good. So let's go to camera.draw. We'll go to definition. And here we're going to transform the object, which was the ship's drawable, and then call draw on the next thing. Now the next thing is going to be in our normal chain of events, it's going to be the viewport. And the viewport again transforms with translation, and then it clips, which is to say it adds a, or it modifies the clipping rectangle that is stored in the drawable object. And then we go to, what's next? The next thing is going to probably be, where is it? It's up here. Graphics. And graphics calls the rasterize function of the object. Now the object that we're using right now is a polyclosed. And rasterize, if we can find it here, is in the drawable. Where's rasterize? There it is, my friends. And rasterize just does the usual. It loops through the vertices and it draws lines between them, connecting all of the vertices, creating a closed polygon. And we call draw line clip, and we use the translation, or not the transformation matrix that was built up in the drawable through the camera viewport chain to transform each of the vertices, and then we draw them. However, we have a problem here. Draw line clip is clipping, but we're not passing it our clipping rectangle. Remember, a drawable object stores the transformation matrix, but it also stores the clipping rectangle. So we're building up a clipping rectangle, but we're never using it. That's kind of dumb. What if we were to try to clip? Where is my viewport? So let's change the clipping rectangle here. We're gonna start the top left-hand corner of our viewport at 300, 300. And let's just build that and see what happens. Nothing happens. We can still see all the way up here. We shouldn't be able to see all this bullshit because of bullshit. Oh yeah, I changed the ship out. The ship model. I changed it to ship try. Or I don't know I think I switched them around for you guys just to trick you. To make you draw the dick on the screen even if you didn't want to. That was my little joke, but yeah, whatever. I changed the ship model. That's it. No biggie. So our clipping rectangle that we use to initialize the viewport is quite, what's the word I'm looking for? Impotent. It's got a little bit of the ED going on there. So what we need to do is we need to go to graphics and we need to modify draw line clip. Go to definition. And we need to modify it so that it takes a clipping rectangle. So we're going to go rect I. I think it's I. It could be F. Actually, now that I'm thinking about it, it should be F. Yeah, that's the thing about this. Because when we're clipping X-min, X-max, these are floats. So we want a floating point rectangle. And we're going to call it clip, not cop. Clip, that's the one. And, okay, so we got X-min, X-max, Y-min, Y-max. Where, okay, they're used all throughout. We're going to do the old copy-paste here, my friends. The old copy-pay, as they say in Japanese. They call it copy-pay. It sounds stupid. All right. So we're going to place X-min with clip dot left. Replace all. 5. Okay. We're going to replace Y-min with clip dot top. I've got a bit of a cold still. Throat's getting a little scratchy. I may cough into the microphone. Be warned, Xmax is going to be clip dot right. Yeah, okay, I got you. And Ymax is going to be clip dot bottom. Oh, I wanted to do that. Okay, there we go. Perfect. Perfect. Now what we're going to do is instead of this, we're just going to go clip. Yeah. I don't know if I want to pass this one by constant. Passing by reference is good, but it's going to cause a problem. Now, we don't want any of this. What else do we not want? We want to pass this by reference, but I forgot how to pass captures by reference. I think I can't for the life of me remember. 1 second. All right, it looks like yeah, ampersand whatever is how we capture by reference. So we'll capture by reference just to save a little bit of memory copying. It's not a big deal. It's not really a deal at all, but it's a thing that I can do if I want. Okay, so that should be fine for using our clipping rectangle. Now we need to change the definition. My definition is this. My definition. There we go. Now the problem is we're passing this by reference. However, our drawable has a rect eye, because I figured since it's going to be screen clipping, an integer will be better. However, that was not the case. So what we're going to need to do is we're going to go to drawable. We're going to change this into a rect F. This one is going to be rect F. That should be fine. Now, where's shit gonna get broken? Shit's gonna get broken somewhere along the line. The question is where? Well, let's see. Brain's freezing up here. Okay, so we got ship. Well, we're gonna have to fix this anyways. So we'll go to poly closed in the drawable here, and we're gonna have to pass it clip. And here we're gonna pass it clip. Now the viewport is gonna clip to this one. However, object.clip wants a rectf, reference to rectf. We're passing it a reference. We're passing it rect I. I don't know if that's going to fly. The thing is, in rectangle, if I can find it here, we have defined a general conversion operator to convert from different kinds of rectangles. So if it calls the conversion operator, we should be fine. It seems like it does. Now let's see if this worked. Okay, so we're not seeing anything up there. There we go. So we are now clipping to our specified rectangle. And yes, I heard you. So let's go to game here. And let's undo this bullshit. And we'll just try that again. So So I mean, there's a thing in which the viewport's clipping rectangle has to be converted from integers to floats every time we clip an object. And that could be a small performance hit. So it might be worthwhile to change viewport from a rect I to a rect F type deal. I think I'll do that right now because, I mean, it's not going to cost us anything. It's super simple. Either way, it's not a big deal. Change this to rect F. Change this one to rect F. Interesting, I don't use references in this one either. Whatever. I'm a little bit, I'm not consistent with when I use references when I pass by value. Sometimes for things like this, I'm kind of like, it could go either way. I don't really know the numbers on that too well. It's not a big deal either way. Here, well, it's not giving me any nasty underlines. Oh, here it's a conversion from float to int, possible loss of data. Viewport draw target. Right. Get width returns an integer. I'm going to change this to float. And we'll see if that creates any new... No, it doesn't. Okay, good. Fine. Fine. Let's go to game. Here we don't have to put the floats in anymore because now get width and get height return a float naturally. See, I'm just cleaning up now. So that was the main problem I had with our code as it was. It was a pretty big problem, and we fixed it, no problem. I said the word problem way too much in that sentence. I'm going to stop using that word. I will call it an issue, a difficulty, a matter. What else do we want to do with our life, people? Sometimes you just got to sit on the edge of your porch with your head in your hands, just, what am I doing with my life? And the answer is always override. I got to use that override keyword a lot because I didn't use it. So I got drawable here, and it's got rasterize as a function. It's a virtual function. And in my, where is it? Fuck you, man. Polyclose, there it is. In rasterize here, I should have done this. I should have const override. This is a new, I've mentioned this before, it's this new thing in C++11. It just explicitly states that you want to override a virtual function. It's a good thing to use every time you're going to override a virtual because it adds an extra check into the compiler. So I forgot to use it, and I'm sorry. Let's use it right now. The other places we can use it are in camera, virtual void draw, override, and in viewport, draw, override. I love decorating my signatures. It's so good. What's up? What's really good? Let's go to graphics, draw, override. So we've overrid the fuck out of this motherfucker. Let's build that. It shouldn't change. Oh, fuck you. I didn't want to build it all, but it didn't matter because it worked fine. Now, what's the last thing I wanted to show you guys? What's the thing I wanted to clean up here? I think that's all of the overrides that I wanted to put in there. Last thing, polyclosed. I like this system with the loader and the polyclosed, but I like it even better if we could just put this as an internal class. Something I've been wanting to do, but I keep forgetting. So I'm going to make it private for now. I might make it public later, because we might be able to reuse this loader somewhere else. But for now, it's private. And like we did with the other ones, like we did with polyclosed drawable, instead of going polyclosed drawable, I just called it drawable because it's scoped to polyclosed already. Do that same thing here. We'll just call it loader because it's already scoped, and we'll get rid of it there. And one more is going to be in here, I think. Yeah. Just call it loader. And then we're done. And one more thing I want to do with this, since we're here already, is instead of this nasty std move in this thing here, which is going to get stds all inside our constructors, what we want to do is what do I want to do here? I feel like there was a thing I wanted to do. Yeah, I think what I want to do is I want to make this an operator. We're going to turn this into an operator for converting to R value references. And we're going to go operator. Yeah. Somehow that's not really right, is it? Maybe it's more like this. Operator, standard vector. Yeah, that's the one. That's the ticket. And then we're going to go std move here. So that will just automatically convert this thing to an R value reference when we want to. And now we can go down here, and instead of calling get vertices, we just pass it the loader. We just call loader file name, and we don't need move because it's going to automatically convert to an R value reference. And this will just automatically invoke the move constructor of this container. So look at this. This is much cleaner. It's much sexier. And you know how I like my code. I like it sexy. All right. So I think that's it. And that's good because my voice is already going. Not much more to say except we did it. We did it. We did it, did it. And next time we are gonna do what's the thing I'm looking for? Collisions, physics. We're going to be doing physics with collisions and stuff, and it's going to be good because we are going to unleash the beast of vector mathematics. This is where the vector mathematics is really going to shine, people. And I'm looking forward to showing you a whole new world, a new fantastic point of view, as it were. Yeah, that's it. That is it. So until next time, unless I think of something else and tack it onto the end of this video, Chili is signing out, wishing you happy coding.